All right, now here's another example that we're going to do. So notice that we could write division problems like this too. Remember, just like in the previous example, I had 7 divided by 2 written as a fraction. We could write our polynomial expressions as a rational expression too that still represents division, right? So again, we're going to do the long division here, okay? So we set it up, our dividend and our divisor. So we set up our x minus 2 divided into, and again, make sure it's in the proper order. So 2x squared plus 3x minus 14, and again, no placeholders needed in this case. And so now we just go through the process of our long division. So we're going to put 2x, x times 2x gives us 2x squared, minus 2 times this is going to give us a minus 4x. Okay, then we're going to subtract, and so when we subtract, this is going to go away. We're going to get 7x. Now we're going to drop down to 14. Okay, now we do the whole process over again. So x times 7, right? So this is going to be plus 7, right? So x times 7 gives us 7x. Negative 2 times 7 is minus 14, okay? And again, we're going to subtract, so we subtract the whole thing. This is going to become negative, that's going to be positive, and look at this goes away, but also this goes away, and we get a remainder of 0, okay? So what does this mean? Well, this means that this division problem is equal to what? 2x plus 7. So if we take this divided by this, we get this. The remainder of 0 also tells us something about this problem, is that these are factors of each other. That what? 2x plus 7 is a factor of the dividend, right? So if we write it the other way, what this is also saying, remember from the division algorithm, we know by this that we can write 2x squared plus 3x minus 14 is equal to what? X minus 2 times 2x plus 7 plus the remainder, but the remainder is 0. So what we can say is that, hey, if we get a remainder of 0, we can factor the polynomial. But again, if you think about back in elementary school when we first started dividing numbers, if we got a remainder of 0, it meant that they were factors of each other, right? So if I took 8 divided by 2, right, that's going to give me 4. And so if we would say, hey, if it goes in evenly, right? In other words, if you have a remainder of 0, like in this case, we knew that 8 it can be written as a product of 2 factors, right? Same thing with polynomials, right? Because remember, algebraic expressions are still numbers, okay? All right, great.